Hello everyone, this is Sophia back with another video. And today we're going to be talking about makeup. That's right. This isn't actually a video about data visualization. This is going to be a makeup tutorial. But I'm kidding, obviously. As you can see right here, I'm on a picture of makeup, but I'm actually on the Tidy Tuesday, once again, the Tidy Tuesday database of data. And we're going to be looking at data about makeup. But before we do that, I'm going to kind of introduce the main idea of what we're going to be talking about, the main types of graphs that we're going to be making out of this data. And those are bivariate graphs. Now, as you can probably guess, bi meaning two, those are graphs with two variables being represented. And there are three main types of bivariate graphs. Here, I'm just going to write it down. Bivariate. Three main types. The first type is categorical versus categorical. So you're comparing one categorical variable to another categorical variable, and that's the first type we're going to be looking at. It'll probably be easier to conceptualize when we have some examples, but I'm just putting these down so you'll have a framework for the rest of the video. So we have categorical compared to another categorical variable. We have two quantitative variables being compared, and that's actually what we did in the last video. If you watch that on the Bechdel test data, we were comparing kind of the year, which is it's a time variable, so it's definitely quantitative. We were comparing a year to a rating, which was also on a number scale. So we had two quantitative variables. That was a bivariate graph that we made. A classic example is scatter plot. The third type, we are comparing a categorical variable and a quantitative variable. And those are common, but it might be a little hard to think of one off the top of your head. But that's a good exercise. If you can think of a categorical versus quantitative graph, but those are used very often. It's a great way of representing data. But we'll go over the three of these in this video, but for now, I'm going to go back to this data just to give you a rundown of what's going on here. So this data, again, it's from this year, from March, and it's about makeup shades, specifically makeup shades that are labeled like nude, like skin color shades. And it's provided by a website or a journal maybe called The Pudding, where they compared a bunch of products from Sephora and Ulta's websites, and sort of got a lot of data from those products. And they looked at a few different aspects of these products, including like their name, what labeling system they used, like was there a numerical system used to like organize these different shades of makeup, things like that. So before we dive into the data, I wanted to say that I would highly recommend checking out this article called The Naked Truth. It uses the same data that we're going to look at today, but they just use it in different ways, and they have very nice visualizations here, as you can see already. That is a little too advanced for me right now in R, but it's some really good stuff. I highly recommend it. But going back to the data itself, so as you can see here in our data dictionary, we have 5 different data sets. So that's a lot, and we're not going to be using all of these. But as I was planning out this video, I was thinking, okay, categorical versus categorical. That's our first type of bivariate graph that we want to I just want to make one from this data, you know? So I looked around, I was like, okay, well, here's a data set called all categories. Categories, categorical, close enough. So let's take a look at what's in here. We have the brand, a foundation, product name, URL. This isn't very interesting to us, the URLs. Word-based name. Here's a good one, categories. Comma separated categories that were assigned to a given label, like food or color. Specific, the number letter combination, that's hexadecimal. We don't really, this is just kind of code stuff. That's probably useful when you're organizing data, but not very useful when you're trying to make a data visualization. Then we have lightness. This is an interesting one. A lightness value from 0 to 1. So the first thing I'm gonna do, just like in the last video, is grab this data, and we can do that easily from up here. And right now I'm just gonna, instead of grabbing all the data at once, I'm gonna take this one data set, the category one. Put that in here. And here we are. And we can see this again, a very large data set, has more than 5,000, I think, type makeup products being looked at here from all sorts of different brands, you know, and so let's take a look at some of this more juicy stuff. We don't really care about the URL. So in this first analysis, we're interested in looking at two categorical variables. So let's look at what options we have. Here we can see we have the names of these different products, and we have categories, which were kind of explained in the article, but you can get the gist from just looking through a few products here. So these are names of like foundations or whatever people put on their face. So these are the names of like foundations, and we have, you know, Shell, and that's classified as like a gem, which isn't the clearest name, but you get the idea. Linen is a textile. We have ivory, which is both classified as a gem and a color. And you get to like vanilla, cashew, those are foods. Yeah, maple, wood, and they're given these like overarching labels to kind of group some of these together. So, because obviously, probably not all of these names are unique. You're probably going to have a lot of like ivory shades out of 5,000 different products, but these are still relatively unique, right? Compared to like looking at a whole category of like food. So this seems like a good categorical variable to look at. And we can look at these sort of categories in relation to something else. So a good choice would probably be the brand. But before we start, you know, just putting random data together, I think it's good to have like a question in mind beforehand. So what are we trying to answer with this bivariate, you know, categorical versus categorical graph? And there are lots of things you could look for, but what I was interested in, and I was kind of inspired by the article, was looking at what choices companies make when they're naming their products. Like, do they tend to go towards like food names, or, you know, animal names? What sort of things do they gravitate towards? And it turns out that has more significance than what you might think, but we'll get to that in a bit. So again, like before, let's start sort of breaking this data down into things we can handle. Again, a good tool that we used last time for preparing data was this Dippler library. So I'm going to run that. And let's see, let's go, and there are a bunch of brands being represented here, a lot. So let's just pick 5. And I'm going to be doing this a lot throughout this video, but instead of typing out all the code like I did last time, I'm going to sometimes just go into my notes and grab some code, because there's a lot of code in this video, and it's going to take me a long time to type it out. So here ahead of time, I just picked some brands. I picked 5 that are pretty popular. You know, I have Maybelline, L'Oreal, Wet n Wild, Elf Cosmetics, Becca Cosmetics. There wasn't a particular reason why I chose these. I just picked a few. So let's run this, and now we have sort of a smaller data set with just these 5 brands. And it's still pretty large, because if you know anything about makeup, you'll know like L'Oreal, Maybelline, they have a lot of products, but we've narrowed it down to a few brands. So now we have a categorical variable that we can really focus in on, like the brand. Because, you know, at least when I think of like how we represent categorical variables, I usually think of like a bar graph. And spoiler alert, that's actually what we're going to be making. But bar graphs, it's kind of hard when you have like, you know, like 500 bars. Like that's not really a bar graph anymore. That's like scatter plot material with just some bars going down. But in a bar graph, you know, we usually have like between like 3 and 10 bars. That seems like a good range. So 5 bars is good. It probably would be kind of uncomfortable if we had more. That's not to say that there aren't ways of representing categorical variables, like a lot of categorical variables at once. And we might get to that when we get to this little last piece. But for now, let's stick with just these 5 brands. And next, we're going to use our, again, very useful ggplot2 library, and we're going to make a bar graph. So actually the ggplot2 function, if you remember from the last video, we used it to make a scatter plot. It's actually really similar for any type of graph you want to make, which is one of the reasons why this package is so popular. But you'll see in a sec. So I label this data set brands of interest. That's the one that just has a few brands in it. So we're gonna, again, put that as our data parameter. And then just like before, we're gonna map 2 variables to the 2 axes. Because again, here we don't really have 2 axes the same way we had in a scatter plot. But if you visualize like a bar graph, you have your labels here for the categorical variables, and you have like a height. Because something interesting about these categorical comparison graphs is that there's always still some sort of quantitative variable. Like these bars have a height. And that's the main way that you compare them, right? So yeah, I just think it's interesting. I just think it's interesting how every categorical, you could say purely categorical graph still has some quantitative element. But that was a kind of an aside. Let's map these things to our axes again. So our x-axis is going to be our brand. It's not going to be a continuous numerical axis, but it's going to have like these brands labeled down below. And next, instead of a y-axis, we're going to have something called fill, which I'll actually explain in just a second what fill means. But you might guess it has something to do with filling in the bars. But next I'm going to hit this geom bar, and if you remember, geom underscore is the exact same like prefix you use for any of these ggplot graphs. So before we had geom underscore like points or smooth if we wanted to make a line, and here we have bar for obviously our bars. And for our parameter, we're going to hit position equals stack. And that is because we are going to be making 3 different types of bar graphs to represent this data. We're going to be using the same data, just 3 different types of bar graphs, 3 different types of representations. And the first type of bar graph is a stacked bar graph, and you'll see what that looks like in a second. And so our categories thing here is that we're going to be filling these we're going to be filling these bars with little stacks, and we want each stack to represent a category. That sounds like a lot of words that don't make sense right now, but I'm going to graph it and you'll see what I mean. Okay, that took a long time because we have a lot of categories and this looks very messy. It looks pretty. I like the color scheme, but it looks very messy. This does not look great. We can't really make a lot out of this, but this is a good chance to explain kind of what's going on here. So as you can see, or maybe you can't see because it's not very clear, but you can kind of see that we have these different colors stacked on top of each other for these bar graphs. So each brand has one bar, just one, not like a bunch of bars for each brand, but just one with different colors stacked on top of each other. And each color has and each stacked item is a particular color, and that color corresponds to the category. So that's kind of what we have going on here when we said fill equals category. And we don't have to specify our y-axis at all, because again, our y-axis isn't really considered a variable, because again, we're comparing two categorical variables, like the category and the brand. But it's kind of implicit when we're telling R to look at this data, make some bars, we're telling it to look how often do each of these categories come up for each of these brands. So what we're going to be doing next is getting rid of some of these variables because there are too many. And you can decide for yourself whether that's a good idea as a statistician analyzing data if you just want to get rid of some variables. I should have phrased that differently. These aren't variables, they're values of variables. And we're going to get rid of some of these values for our categories. Because the problem is that so many of them overlap that we end up having like something that's a descriptor, a color, and an animal. Maybe it's like pink zebra, I don't know. But we have some of these going on that we have way too many categories. Just for those 5 brands, we already have all these different categories. So let's get rid of some of these categories. Okay, sorry. And the way we're going to do that is we're going to use another library, a new one called Stringer. And this library is mainly used to analyze strings. And if you're familiar with computer science at all, strings are sort of words. Let's just leave it at that. They're words or groups of words, just a bunch of letters strung together. And that's going to be useful if we want to pick out different things from this. This is best illustrated with an example. So let's use this stringer function, but also use something that we used in our last video, which is the mutate function. And we're going to use it to combine a bunch of these different categories. So let's start off with this, like brands of interest, mutate, take this data set, and we're going to set categories equal to. So we're going to mutate this variable, categories. And we're going to use a function that is actually part of base R. I know, no package needed, but it's the if-else function. And again, this is kind of, if anyone's taken comp sci, this is reminiscent of like computer science, where we're going to have sort of something for this method to test. We're going to ask it, okay, look at one of these categories and test something. And the first part of this, if that test is like passed, we're going to do one thing. And if it's not else, we're going to do something else. And let me put this in and it'll probably make more sense. So actually, before I do that, I'm going to explain what I'm trying to do here. I probably should have done it before. So basically my goal in condensing these different categories is to say that, you know, instead of like food, drink, let's just make one category with everything that has food or drink included. Let's just make that one category. Let's say I'm really curious about like what brands use labels that involve food or drink. And I don't care if along with food, there's also like a skin color. I just care that it has food in it. That's most important to me. Or I care if it has a drink. So I'm gonna make one category that's food and drink, and that's gonna give 1, 2, 3, 4, 5, 6, 7, plus more, because some of these have food, drink, sprinkled among the other categories, but I'm gonna condense those all into one category called food and drink. And I'm gonna do that by using this if-else method, sort of a method within a method. And so the first thing we're gonna do is we're gonna go over these categories, and we're gonna say if it has food in the name, not necessarily just food, but it could have food, comma, color, but if it has food somewhere in the name, let's assign it to that food drink category, that new food drink category that we're about to create. And the way you do that is by using the, sorry, I'm getting strange sounds, str_detect, which str I'm assuming stands for string detect, where we're detecting a string, again, a string of characters. And we're going to search the categories variable for the string food. And this little segment of code is going to return true or false. And depending on if it's true or false, again, that's that test I was talking about earlier. We're gonna assign that object, that category, one of two things. So if it has food, if this comes back as true, we're gonna assign it to the category food, drink. So again, if this comes back true, we're gonna set the name to food/drink. So all of these would come back as food, drink. But if it doesn't have food in the name, like color, we're not gonna do anything. We're just gonna leave it be. And we represent that by just writing it categories. We're gonna, whatever was in the categories labeled before, we're gonna keep it that way. We're not doing anything to it. So let's run this and you can see how this is gonna work. Now we go in here. And now, yeah, these things before I think were labeled food, food, food. Yeah, vanilla, cashew, and now they're in their food drink category. But that's nice because now we don't have any of these like food, comma something. And here, just for the sake of interest, let's graph this again. And yeah, it doesn't look a whole lot condensed, but it is. You can actually see this label category speaking out now. It wasn't there before. But what we did is you'll now see that the only time food shows up is in this label right here. It doesn't overlap with anything. And so we've reduced the number of total things that we have. And so I made a food drink category here. Let's add the drinks there too, so we can get rid of those too. Oh, copying the wrong thing. Now, instead of looking for food in this string detect method, we're going to look for drink. And we're going to do the same thing. We're going to set it to food drink if it finds drink in the name of the category. All right, that should be good. And now let's run this one more time. Okay, so now you can see it's even shorter. And these bars, I think, look a little clearer. You probably have a disproportionate amount of green right now, but we'll fix that later. But yeah, you see now food and drink only show up in this one label. We've grouped them all under one color. And now this is a bit tedious, so I'm gonna go, writing all this out is a bit tedious. So I'm just gonna go into my notes and I'm gonna copy all these, but I am gonna tell you what I did at least. All right, let's take all of these, copy them in here. So I chose a few different things that I wanted to group together, not just food and drink, but let's make like an animal plant category. This one doesn't belong. let's make an animal plant category. In the same way we did with food and drinks, anything that has animal or plant in the name, we're going to put under one category. Same with gems, rocks, metals. Those all sounded pretty similar to me. So I decided let's put them on into their own group. So here's where we stopped. Let's run all that. And now I'm not going to run this once more, but you get the idea. We now have some of these are still here. This like color complement is still going to be there, but now we have some like main ones that we've grouped things under. We have like a gem, rock thing, animal, plants, food, drinks. We have our main categories that we're interested in, or that I was interested in when I made these. When I kind of subsetted this these categories. Yeah, actually, let's graph this, and I'll explain what we're going to do next. Okay, so this looks a lot neater, to me at least. You know, we have our colors pretty neatly stacked. Again, we still have some of these weird ones, but we have some main categories. And what I'm going to do now is probably of limited usefulness if you were actually trying to make this an accurate representation of what is going on. Let's say I'm just interested in these categories that I've created. I'm interested in what these brands, like how often do they make food or drinks as their names, or animals or plants as the names of their products. So I'm going to delete all these like little extra categories that were left over, and I'm just going to stick with the 3 that I created. And again, if you think back to our last video, see everything's kind of being tied together. I'm going to use something that we used then, which is this filter method. And I'm going to filter for the categories that I want. And again, I'm going to copy this because it's a long line of code. There we go. Now I said I'm going to filter it so that categories is either equal to food or drink, animal or plant, or gem, rock, metal. I'm going to run that. Now we've deleted all of these. And once more, I'm going to graph this stack. And I promise that was the last of the weird like data preparation that we're going to do. Yeah, there we go. And I can kind of start to see something useful coming out of this data. We just have 3 colors, and you can see that it looks like overall food and drinks seems to be the most popular out of these 3 categories. But also that could be accounted for by saying that that's the one we did first. That's the thing we filtered. That's the thing we looked for first when making categories. So if we had an animal, so if we had like animal and food categories, like if you had like sauteed lion, like I doubt that's like a actual, there were easier examples. I'm sorry, like asparagus, like roasted asparagus. I doubt that's going to be like a nude skin tone, but again, it's a plant, it's a food, but it's just going to be counted as a food because that's the one we did first. We said if you find food in the title of the category, call it a food. So that could be one reason why green is in the majority. But also, I think that these 3 are pretty mutually exclusive. I don't think you're going to get that many like rocks overlapping with food or drinks overlapping with animals. So yeah, it looks like animals, plants aren't very popular. Food and drinks are, followed by gems, rocks, and metals. That seems to be the general trend that we can see. You know, this might not be too great for comparing the like different brands. Yeah, this might not be too great for comparing the like proportions that different brands use to each other, just because all of these are different sizes, and this is determined by how many products are counted for each of these brands. So L'Oreal, Maybelline, there's a bunch, and so these bars are taller than the others. Even though if we were really concerned about the categories, it would probably help if they were the same size. And we are going to actually make a bar graph like that later in this video. But for now, we've done a lot of like raw work, like making these categories clear. And we've come up with a stack. Again, this is called a stacked bar graph. We're comparing two categorical variables, these categories and these brands. And now I'm happy to say that a lot of this coding is going to get easier now. No more of this, all these mutations. Okay, so we're going to make a similar bar graph, but this time we're going to make something called a grouped bar graph or bar plot. And we're going to, all this is going to be the same. Actually, this is not the code I want. I'm sorry. Let's go back to our ggplot code where we made our bar graph. All of this is going to be the same. Again, like I mentioned, these are super regular in their format. So same mapping, same data set. The only thing we're going to change, we're still going to have bars here. We're going to make this, we're going to set position equal to Dodge, and you'll see why in a second. Let's graph this again. This is going to be a grouped bar plot where instead of one big bar for each brand, we're going to have them have their own like separate bars for each of these. And this can be useful. Say we wanted to really just look at one brand at a time. We weren't concerned at looking at them all at the same time. It's convenient that they're on the same graph, but let's say we wanted to focus on like Becca Cosmetics. And this might be easier for most people to see than like one stacked bar chart. You might think like, oh, I'm not sure which one of these is really bigger if they're all just stacked into one big stack, especially for, say, this one, L'Oreal. Here we can clearly see they're about the same size, but if they were all stacked like they were before, here we can actually, convenient tool, let's look back. I can't really tell here which one is bigger. Or I might say like, to me, like the blue one looks a little bigger, but here we can see, oh, hey, they're the same size. So that's one convenient thing about the grouped bar plot. And the reason I remember it as Dodge is that instead of piling on top of each other, these bars are dodging each other. I don't know if that's the reasoning behind it, but that's how I remember it. The only thing that kind of looks a little weird to me here is that all of a sudden you have these like thicker bars in Maybelline because you don't have any products that fit this animal plant label. And the reason that might be a problem is that the reason we use bar plots in the first place is that humans are pretty good at judging areas of like bars, but they're not when they don't have a uniform side length. So now these are the same height as these would have been with the same amount, but they look bigger to us because they have a bigger base. And so that's kind of a distortion of what's actually going on. So with a quick modification to this, we can make these the same width as the other bars. And that's, again, not anything that's hugely important, but I just think it's a good touch to have. So here, instead of just setting it to Dodge, we're going to have position equals position underscore Dodge, and we're going to have preserve equals single. To be honest, I'm not sure what this means. Maybe it's like you want a single size, single width. I don't know, but this is the syntax that you want to use. Position Dodge, and then preserve equals single. And yeah, now you can see instead of having these be thicker, we just have a little empty space here where there's no fitting category. And I think that looks a lot better. So yeah, these are stacked. Sorry, I keep saying stacked. The ones we did before were stacked. These are grouped by like brand. Yeah. And the last type of bar plot we're going to do is our segmented bar. And segmented bar plots are what I was saying might be useful to us before when I was talking about these stacked bar plots. Sorry, going back here. When I said that, they're different sizes, so it might be a little hard to compare the proportion of these categories that are found when you're comparing two brands. So I'm not sure, like, does this contain proportionally more green than this? It's kind of hard to say because obviously this green rectangle is bigger because there's just more makeup products in total, but is it like proportionally more, So the solution to that is to use something called segmented bar plots. And again, similar format to what we were doing before with this ggplot function. All of that stays the same. We're going to remove this thing. And now inside of there, we're going to do position equals fill. And we're going to have, this is the important part. Actually, if you remember, this lab is usually used for like our axes, our labels. And we're going to set y to proportion. Yeah, and actually, I think this doesn't really matter to the plot itself, but it is going to give us a proportion label on our y-axis. Yeah, so this label is just, instead of count, we're going to have a proportion here because we're going to be, all of these are going to be the same size. So we've adjusted for the differences. Basically, all this is doing is adjusting for the differences in the number of total products that they've released. So we don't really care that, say we don't care that Maybelline released way more products and went wild. We just want to see their proportions of these different categories, and this will help us do that. And this parameter fill is telling us to make a segmented bar plot. Let's run this. And yeah, we end up with something looking like this, where at this point we've accounted for the differences in the number of products, and we just have proportions. It might be a little hard to read the exact proportions. You'd have to go down here and say, like, okay, this looks like 0.3, this looks like 0.8, maybe. So maybe this is like about half. But it's not as easy as if the bars are next to each other. But they do give us a nice, like, proportional outlook. So here we can see, yeah, they all seem to have about the same distribution. You have less of this animal plant category. Maybe about half, or a little less, are made up of these food and drink, and then a little less than half from these gems, or rocks, or metals. So this is our third and final type of bar plot. So we've gone over 3 different types: segmented, grouped, and stacked, or stacked if you prefer something with a little more color. But I think this conveys information a little clearer, even if it doesn't have less like total categories that we can look at. But yeah, that was kind of this first category of bivariate graphs. I've been saying category a lot today, but categorical versus categorical, we're comparing brands, a categorical variable, to a category, a categorical variable. So there you go. And I think I'm going to end the video here. And next time we're going to talk about quantitative versus quantitative, and maybe we'll get to categorical versus quantitative. But I hope you enjoyed, and thank you for listening. See you next time.